All right. So these are going to be the notes for the next part of your packet here. So if you look at your packet, it'll be on page 10. All right. So we're going to start on page 10 with these. I'm just going to put that off to the side here. So with the notes here, they're similar to last time. The colored words are the ones that you'll be writing down, and I think I fixed them all, so it truly is the colored words that you'll be writing down here. So let's go ahead and start that. Let me go back here. Okay. All right. So I'll make this screen bigger here in a second, but I just wanted to show you about where this is going to go. So it says there are 3 big pieces of evidence for the Big Bang Theory. So you'll put the number 3 right up here on that line on the top of page 10. And then it says the 3 big pieces for evidence are A, B, and C. So what you'll have to do is at one at a time here, write background radiation. So that goes in this box right here. In the box it says A. And then what is it? You're going to write down this part right here that comes after the colon and put that right in here. Okay. So background radiation goes here, and an echo from the Big Bang goes here. Abundance of elements go here, and large amount of hydrogen and helium go here. Redshift goes here, and then distance and movement of galaxies goes here. And then the rest of it will go through one by one, and you'll be able to fill those in. So I'll make this bigger here. So these are the 3 pieces of evidence that we'll talk about more in depth here. The first one we've mentioned already, and we've talked about this, and you've seen them in a couple of the videos here. Background radiation, that leftover radiation that we can hear sometimes and see that we theorize is left over from the Big Bang. Abundance of elements. So there is a large amount of hydrogen and helium in outer space. And hydrogen and helium, if you'll notice, on our periodic table, are the first 2 elements on the periodic table. And so they're the most common. And we'll kind of discuss why here in a little bit. And then redshift, we're going to briefly kind of discuss that today, but we won't get too deep into that until next time. So if you, I'm going to move on, but the sub can pause the video here to make sure that you guys get this all written down in the boxes. So again, you're only going to need to write down color words that come up that are fill in the blank for the information that's in the 3rd column there. So remember that the first atoms were formed about 379,000 years after the Big Bang. We have these atoms right here, the single protons, those are hydrogens, right? And the single or the 2 protons with the 2 neutrons are helium. So they've attracted a little bit more. And then they all have electrons that come around them and start circling. So these are the full-on atoms. So the process of atom formation, so you want to write that down, atom formation released an incredible burst of energy. And this energy released billions of degrees of heat. Okay, so getting these atoms together releases a lot of heat and energy that was thrust out basically into the universe as we combined these protons and neutrons together. And again, remember that the universe had to cool a little bit in order for those electrons to come around. So you can see here as they combine, those electrons combine, you get heat being released there. Oops. So scientists have hypothesized that the temperature was so hot that the universe is still cooling. They estimate that the burst of energy was so powerful that it left an echo or a fingerprint behind. So again, that burst of energy that was released is still cooling the planet, and it's leaving behind some sort of what we call echo or fingerprint. And this was what we had discussed in terms of what was left over from the background radiation. So these next parts here, you don't have to write anything. But these were the two people that discovered the echo. These were the ones they were talking about in the video that had the pigeon problem on the satellites that they kept seeing pop up and thought it was the pigeons and cleaned them off and sent them away, and it still showed up. So in 1964, Penzias and Wilson accidentally discovered the echo. They were working on a very sensitive radio telescope. Again, that would point out into the space and bounce back. So this telescope picked up an unexplainable radio static. You guys have all heard static before when you go to turn to a radio station that, doesn't fully come in. And it was later concluded that this static was an echo left over background radiation from the Big Bang. So this here is called the W map. It's a map of all the leftover radiation showing clusters and temperatures of the entire universe. We have pockets where it is cooling, and we theorize that those could be like black holes. We have pockets where it's still, the temperature is still high, so it's still cooling. So again, they've been able to track sort of heat temperatures throughout the universe and come up with this map here. All right, so this is old school. A lot of you probably don't even recognize a screen like this. But if you were to turn on your TV without satellite or streaming or cable, if you were just to turn to like regular old channels on your TV, a lot of times most of them wouldn't come in, and you would get this sort of fuzzy background and this sound that would also pop up, and I'll play that here. All right, so if you watch older movies or something like that, you might see that there. This is the wavelength of that signal that you can still hear from the TV, but this is theorized to also be a fraction of what we are seeing left over as far as static goes. All right, so we're moving on to filling in more of letter B, which was abundance of hydrogen and helium, and we said that these are the most abundant elements on Earth. They're also, again, the first two on the periodic table. So George Gamow hypothesized that the heat and energy of the Big Bang created all the hydrogen and helium in the universe. So basically, all of the hydrogen and helium that has been around forever was created at one single moment in time. And he also helped prove that 99% of the universe is made up of hydrogen and helium. And I think I might have mentioned that in the previous video, is that hydrogen and helium make up are the main components of stars. There are a few other components, but there's nothing more common than hydrogen and helium. Now, as far as planets go, like physical planets like ours, that's not the case. We're not mostly made up of hydrogen and helium. We're made up of bigger elements, and we'll get to that a little bit later next week. All right, so periodic table here, here's your hydrogen, here's your helium, numbers 1 and 2 on the periodic table. So these are the two smallest atoms and would have been the easiest to build. Hydrogen just has the one proton and not even a single neutron. So it just needs the one proton and one electron. Whereas helium had the two protons and the two neutrons with it, as well as two electrons. All right. So, with this activity here, I'm not going to, make us go think about this one too long because, I know for my group of students, we may not have come across a ton of these yet in terms of chemistry and naming compounds. But we should be able to, come up with maybe a small list here. So, what are some things that have hydrogen in them? All right, so on the very, very bottom of your page, on page 10, I want you to write down, just take about, you know, maybe 30 seconds here to think about some things that have hydrogen in them in terms of their chemical formula. You don't have to list down the chemical formula. If you know like their more common name, you can definitely just write that as well. So let's see what you can come up with. I would assume you might be able to come up with one or two. All right, so see if what you come up with just by yourself. This is just by yourself. So take about 30 seconds. All right. Now, well, you kind of already did that as far as the writing part goes here. So I want you to compare your list there with your table partners. So take about 30 seconds to compare your list to them and see if they got anything that you didn't. All right. And then I'm not there to kind of share your answers, here with the class, but I do want you to write down a few of them that I would, maybe have here. Let me move down a sec. I'm going to move that. I'll leave that there. Let me insert a new slide here so I can write on it. Okay. So I'm assuming that all of you had water. Water is H2O. All right. It's too hard for me to write the chemical formulas with the subscripts and everything on here, but I'll just make a list. And then we also have, like, last year you guys would have talked a lot about glucose or sugar, which is C6H12O6. That was what's involved in photosynthesis and cell respiration. Sorry, I'll make this a little bigger here. So if you don't have this if you don't have the ones that I'm coming up with on your list here, you should add that to it. And you could have some more that I'm not there to see, and that's good too. Hydrogen peroxide. So this is like the stuff that you might have at home. It's usually in a brown bottle, and it's used as a chemical to put on, cuts or burns or antiseptic. Like hydrochloric acid. You may have heard of that before. It's a strong acid. Doesn't have to be. It can be pretty weak too. Methane. Methane is a important gas in the atmosphere when it comes to greenhouse gases. It's released from the stomachs of animals. All right. There's something called ammonia, which is NH3. It can be used as a cleaning product or something similar to that. Let's see. Just liquid hydrogen is known as H2. And then helium gas, also like the helium gas that you use to fill up balloons. Well, I guess we're just going over hydrogen, so maybe I won't include that one. Right. A lot of like fats, oils, butter, things like that. Those things have repeating what we call CH strands, carbon and hydrogen strands. So that's another one that you'll see there. So again, this is just a very, very small list, but you can tell that hydrogen is involved in just about everything, or a lot of a lot of things that we use in our daily life. All right. So let's move on to letter C, which is the distance of galaxies. And you'll fill this in here. So you got 3 things to fill in. So most galaxies are moving away from Earth. And so you can see in the animation that we show that happening. And they're continuing to move away from Earth. We'll talk a little bit more about how we can measure that in our next set of notes here, but we can tell that things are moving away still, which means that they were moving away earlier. So galaxies are farther away and are moving faster. We can also see that the speed is increasing. So what this tells us is that the universe is still expanding. The edges, we have not really reached the edges of the universe yet. So make sure you fill in all of these. They pretty much are all coming up here at the same time. And if all galaxies are moving away from each other now, then they must have been closer together a long time ago. All right, so you can see in the animation how we bring them back together when we go back in time. So I'm going to actually stop there for this set of notes, and we're going to continue to talk about these distances and how we know that. And we'll spend a lot more time on those separately. So I'm going to stop the video here.